right? O is a point object which is at a height of 30 centimeters above a glass slab. Glass slab thickness is 12 centimeters. Below the glass slab is a mirror, plane mirror. Find out where the final image forms. Can one of you tell me the idea? What to do?
So can you repeat the question one?
There is a glass slab, as you can see. Its thickness is 12 centimeters. Its refractive index is 3/2. The lower surface of the glass slab is silvered, so it behaves as a mirror. And above the glass slab, at a height of 30 centimeters, there is a point object. You need to find out where the final image forms. So what can be done? Okay, light from the object enters into the glass slab first, continues, like I'm taking a ray which undergoes normal incidence, so it continues straight, strikes the mirror and gets reflected straight back. This is one of the rays. Okay, incident, refracted, reflected, again refracted out. Okay, you consider another ray, maybe incident like this. The ray is incident from air into glass. It should bend towards the normal, bends towards the normal like this, and gets reflected from the glass surface, not glass surface, gets reflected from the mirror like this, and finally it enters from glass into air, so it deviates this way. So the final image could be forming somewhere below the upper surface of the glass slab. We don't know where exactly it forms, but this is what happens with the light. So imagine what all is happening or what all steps are involved here. First, at the upper surface of the glass slab, let's call that surface as S1. Light refracts at S1 as it enters into the glass slab. Okay, so at S1 there is a refraction that will happen. Then it enters into the second medium, that is glass. As it travels through the glass, the lower surface of the glass is a mirror. It undergoes one reflection. So there is one refraction involved, first one. Refraction at S1. Then the light gets reflected from the mirror. Once the light is reflected by the mirror, it starts traveling upward. Then as it travels upward, it will again go from glass into air. So there is a refraction at S1 again, while the light is traveling in the upward direction. So you have to find out where the final image forms. Try this. And what is the idea when multiple reflections or refractions take place? The image formed by the first reflection or refraction acts as an object for the second one, and so on. Okay, so keep that in mind and solve. Any answer? Okay, let's discuss this step by step. Rishi, suppose you want to find out where the image forms after the first refraction. Okay, you can see how the light has bent after the first refraction. It has bent towards the normal. So it appears to be coming from maybe somewhere here. This straight ray is traveling like this. So after the first refraction, the image seems to form somewhere here. Let's call it I1. Rishi, can you tell me how to find out the distance where I1 forms? Okay, anyone? How to find out where the first image I1 forms? Image formed by a flat refracting surface.
One by, sir, I'm not sure.
Okay, anyone else? Fine, listen. For the first refraction, this is the object distance. Positive or negative, we'll see, but 30 centimeters is where the object is. You need to find out where the image forms. And it's an image formed by refraction. No, you can use the spherical surface refraction formula, but when you apply spherical surface refraction formula to a flat surface, it changes into the apparent depth formula. That's all. Okay. So for refraction at S1, that is the first step, you can write apparent depth is equal to, see, apparent depth, and the same formula can be used for apparent height also. Okay. So apparent height is equal to actual height 30 centimeters into mu2 by mu1. For the first refraction, light is entering from air into glass. So glass will be mu2, air will be mu1. So 30 into 3 by 2, 30 by 2 is 15, 15 3 is 45 centimeters. Okay. The diagram is not to scale, but the first image forms at 45 centimeters. The apparent height is 45. Okay. Now for the mirror, which is basically the base of the glass slab, the rays will appear to be coming from I1. Okay. The angle at which they are striking the mirror, it is as if they are coming from I1. That is why we say I1, which is the image of the first refraction, image formed by the first refraction, behaves as an object for the next thing that is happening, that is reflection. So I1 is the object for the mirror. Okay, you all look at the diagram carefully, and one of you tell me, where will the mirror form the image now? I1 behaves as the object for the mirror. Where does the mirror form the image? Anugrah, any answer?
57 centimeters behind the mirror.
57 centimeters below the mirror. Because I1 is at 57 centimeters in front of the mirror or above the mirror. Then it's a plane mirror, no? It will form image at the same distance on the lower side. Okay. So the mirror forms the image here. Okay. At a distance 57 centimeters from the mirror. You can call that as I2. Okay. So upon reflection from the mirror, the light bends as if it is coming from this position, this way. Fine. Then after getting reflected from the mirror, light starts traveling in the upward direction. It again has to go from glass into air. So it undergoes one more refraction. For that refraction, which is happening here, where do the light rays appear to be coming from? They appear to be coming from I2, the image formed by the mirror. Where did the mirror form the image? 57 centimeters below it. Okay. For the second refraction, that is finally when the rays are leaving the glass slab, I2 behaves as the object. Okay. Again, it's refraction at a flat surface only, no? Finally, when the light is leaving from the glass slab into air, it is undergoing refraction at a flat surface. So you can apply the apparent depth formula. you need to find out where the final image forms. Okay, I'll show you in the diagram. Final image will be forming somewhere here. According to the rough ray diagram that I have drawn, this is the final image that we are looking for. Okay, so we are indirectly looking for the apparent depth from that refracting surface when we know the actual depth from that refracting surface. How much is the actual depth? 57 plus 12, 69 centimeters is the actual depth from that flat surface. For that, you have to find out apparent depth now. Third step. Apparent depth is equal to actual depth into mu2 by mu1. One of you tell me, for the last refraction that is happening, okay, where light is coming this way and leaving this way, how much is mu1 and how much is mu2? For the final refraction, where light is leaving the glass slab, it's coming from here and bending like this. How much should we take mu1 and mu2 as?
Sir, mu1 is 1 and mu2 is 3 by 2.
Why? Rishi, generally you tell
Sir,
me, which medium should be considered mu1 and which should be considered mu2? Not in this problem, generally.
the medium which the rays go from is
the medium in which the incident rays are present is the
mu1, sir.
mu1. So you watch carefully and tell from which medium to which medium is the light going finally?
From the 3 by 2 medium.
From glass into air, no, from 3 by 2, it is going to 1. So which is mu1? 3 by 2 is mu1. Okay, and 1 is mu2. So it becomes mu2 divided by mu1, 3 by 2. You get 69 into 2 by 3. This becomes 23 into 2, 46 centimeters. So the final image I3 forms at a distance of 46 centimeters below the glass slab, below the upper surface of the glass slab. Okay, this is a very important case actually. I thought you will all solve it off readily. Okay, anyway, let's go through this once again. There was an object, a point object placed at a certain height above a glass slab, and the glass slab was silver coated below. Okay, so the lower surface of the glass slab behaves as a mirror, and you are asked to find out where the image forms. Okay, so you have to first imagine light from the object striking this optical system. When light from the object first strikes the glass slab, upper surface of the glass slab, it undergoes one refraction. Okay, that's the first thing that happens. Then after refracting at the upper surface, at the lower surface, it undergoes reflection. That is the second thing. And once it's reflected from the lower surface, while coming up, it undergoes another refraction. That is the third step. An image formed by the first step behaves as object for the second step. Image formed by the second step behaves as object for the third step. And image formed by the third step is what we are looking for. Okay, and since these are flat surfaces, we use the apparent depth or apparent height formula. So what happens is if there's an observer somewhere here, fine, that observer will be able to see this object directly. They will see its image here. Okay. Fine, let's try another problem like this. This problem also some of you might have solved already, but try it once again. Suppose there is a concave mirror, okay, placed like this with its principal axis vertical, reflecting surface in the upward direction. and water is filled up to a certain level in that. You can ignore the thickness of water. Okay, water is filled like this. Water refractive index is 4/3. Assume there's an object at a certain height. Maybe 60 centimeters. Okay. Yeah. From where? From the water surface. Of course, from the mirror also it is 60 only. I'm asking you to ignore this thickness. Just for you to be able to visualize properly, I have shown the thickness. But let's assume this is very small. Okay, that point object is at a height of 60 centimeters above water, above the water surface. Find out where the final image forms. And I have to give you the radius of curvature of the mirror. Assume the radius of curvature is some 20 centimeters. Okay. Solve this carefully. See, first imagine light traveling from the object in the downward direction and what all happens with it. When light travels from object in the downward direction, first as it enters from air into water, it undergoes refraction. Then when it travels inside water, at the other side, it undergoes reflection. And while coming back, okay, the reflected light again undergoes refraction when it goes from water into air. And finally, the rays that come out of water is what we see. That's the final image. Okay. Try this, all of you. Okay. Can any of you tell me where the first image will form after refraction at the upper surface of water? Okay. Isha, what have you tried? No response. Shashank? Okay, I got one answer for first image as 80 centimeters. I think that is correct only. But why are most of you not able to solve? Light is entering from air into glass. Sorry, from air into water. That too, it's entering at a flat surface. So you can trace one ray like this, it gets reflected also. So incident ray, refracted ray, then reflected from the mirror, again refracted. So this is one ray. Okay, we can extend it upwards. Image has to form on this. Okay. Another ray you can take incident this way. Now what happens after reflection and all we will see. It was traveling in this direction. It bends towards the normal. When it enters from air into water, you know light bends towards the normal. So maybe bends towards the normal like this. Or okay, let's make it bend only a little bit as if it is coming from somewhere here. So it may bend towards the normal like this as if it is coming from somewhere here. This is where the first image forms. Okay, after the bending of light at the water surface. And for this, since the water surface is a flat refracting surface, you can use the apparent height formula. Apparent height is equal to actual height into mu2 by mu1. Mu2 is 4/3 divided by 1. Because first light enters from air into water. So water will be mu2, air will be mu1. This becomes 80 centimeters, correct? So light after entering into the water appears as if it is coming from I1, which is at a height of 80 centimeters above the water surface. it appears to be coming from there. So I1 now behaves as the object for the mirror, concave mirror. Okay. We next have to find out where the mirror will form the image. So what happens after reflection from the mirror is what we need to know. For the mirror, object is at 80 centimeters in front of it. I asked you to ignore the thickness of water, no? So you'll assume from the mirror also object is almost at 80 centimeters. Okay. Then apply the mirror formula. 1 by V plus 1 by, rays are striking the mirror in the downward direction. So this side will be considered positive for the mirror and this side will be considered negative. Object is on the negative side. So minus 80. 1 by V plus 1 by U is equal to 2 by R. It's a concave mirror. R should be taken negative, minus 20. So you get 1 by V is equal to 1 by 80 minus 1 by 10. 1 by 10 is like 8 by 80. We'll take it like that. So this effectively becomes minus 7 by 80. So V is minus 80 by 7 centimeters. 80 by 7 is 10 point something, 11 point something. So after reflection from the mirror, the rays will meet at this point, at this distance, minus 80 by 7. So negative side is what? Upper side. And at a distance of 11 point something, 11 point something will be somewhere here. So okay, wait, 10 point something will be here. So after reflection from the mirror, the light rays meet here. This is I2. Actually, okay, I should not draw it continuously till there because light doesn't go till there along that direction. So light travels as if it is going to meet the other ray at I2. Is this step clear to all of you? Any doubt in this? Rishi, did you understand?
Yes, sir.
Shashank?
Yes.
Okay, so after reflection from the mirror, rays are traveling as if they would meet at I2, which is 10 centimeters, or not 10, sorry, 11 point something centimeters above the mirror. Okay. But while traveling towards that point I2, light undergoes another refraction. It enters from water into air. Okay. So now that I2 will behave as the object for light going from water into air. Let us look at that separately. This is a virtual object now. Just a moment, let me make the diagram clear. This is where many of you might have gone wrong. Okay. Now there's one incident reflected, refracted ray like this. Right? Image has to lie on this ray only. There's another ray after reflection from the mirror. It is traveling this way. Okay. And had there not been another refraction, they would have met here at 80 by 7 centimeters. Okay. That is I2. For the refraction of light going from water into air now, finally the light that leaves the system, I2 is the object. Okay. Should we treat it as apparent height, apparent depth? Actually, the formula is the same, no? For apparent height or apparent depth. You can treat it whatever you want. You will directly get the answer. So the final distance, the final image, let's just like visualize first. Light rays traveling towards I2. You can imagine a normal here. If you visualize, no, your chances of making mistakes, especially with the minus signs and all, will reduce. Visualize a normal here where the light enters from water into air. Water into air, denser to rarer medium, it should bend towards the normal. It should bend away from the normal. If that light bends away from the normal, finally it meets the other ray here. This is the final image position that we are looking for, I3. So the answer for I3 should be less than 80 by 7 centimeters. That's all. Use it directly now. Apparent distance is equal to actual distance 80 by 7 into mu2 by mu1. It is going from water to air. So air will be mu2, water will be mu1, 4 by 3. 3 will go to the numerator. 80 by 7 into 3 by 4 becomes 60 by 7. That is where the final image forms. So you can think about it once again, the entire procedure. If you have any doubts, you can ask. Anugraha, where were you stuck? Did you get this answer?
Sir, after the second, you got V is equal to minus 80 by 7. I do not know how to proceed after that.
Okay. Okay. Rishi, did you understand?
Yes, sir.
Okay, fine. Shashank, is it clear?
Sir, can you explain again?
Okay. See, first light from the object O enters into water through that flat refracting surface. So when light from O enters into water, it bends as if it is coming from I1. Okay, so we have to first find out where I1 forms, where the image due to the refraction at the water surface forms. O is the original object. Refraction is happening at the water surface, which is flat. So we used apparent height formula to find out where I1 forms, first image after refraction. Is this part clear?
Yes, sir.
I1 forms at 80 centimeters from the water surface. Okay. Now, that first image formed by refraction at the water surface behaves as the object for the reflection at the glass. Mirror, reflection at the mirror. So I1 is the object for the reflection of the mirror or from the mirror. So how far is it from the mirror? 80 centimeters. Actually, from the water surface, it is 80 centimeters. We are ignoring this thickness. Then you can say from the mirror also it is 80 centimeters. So object distance from the mirror is 80 centimeters. We use the mirror formula and we got the image distance as minus 8, like 80 by 7 on the same side as the object. Is that part clear?
Yes.
80 by 7 on the same side as the object is this distance. 80 by 7. Okay. So light which is traveling from the mirror upwards is traveling as if it would meet the other ray at 80 by 7 centimeters here. But when it is traveling that way, it undergoes another refraction at the water surface. And there it is going from water into air, denser to rarer, it bends away from the normal. Final image forms here. And for that final image, I again use the apparent height formula. Original height, for the final refraction, the image formed by the reflection, this I2 is the image formed by reflection from the mirror. This becomes the object, okay, for the refraction that is happening here. So I treated I2 as the object and found out the image distance, that is I3. I3 is forming at 60 by 7 centimeters. Okay, all of you, if you still have any doubt, you can ask. Okay, fine. In the last worksheet, I had given you one question asking you to derive the focal length of a silvered lens. Have any of you done that? Like suppose a lens like this is coated on one side, silver coated on one side. What is the focal length of this system? One question was given. Okay, fine. If any of you have tried, you can tell. Otherwise, we'll discuss the solution now. So basically, a lens which has been coated like this on one face is a combination of a lens and a mirror placed close to each other, very close to each other. So this system is the combination of these two. We have to find out the focal length of this. Okay. The lens focal length, let it be FL. Mirror focal length, let it be FM. In terms of those two, we have to find out the focal length of the lens, a silvered lens. Let's see how this can be done. Can any of you define focal length? What's the basic definition of focus and focal length?
The distance between the pole and the compass.
Okay, what is focus?
The point where reflected rays converge.
What, in which case? Refracted rays don't always converge at the focus, no?
When the incident rays are parallel to the principal
When
axis.
incident rays are parallel to the principal axis, correct. So we'll have to assume object is at infinity. Basically, focus is the image location when object is at infinity. That idea we are going to use. Okay. So suppose rays are striking this silvered lens. Okay, now see, for all of them, you can assume this is the principal axis. Suppose parallel rays are striking this silvered lens like this. Okay, you can just treat it as a combination of a lens and a mirror, as I said. So we'll first have to assume that the object for the lens is at infinity. Okay, because rays are first striking the lens only, no? Parallel to the principal axis. So for the lens, the object is at infinity is how you are supposed to treat it. We'll find out where it will form the image. Image formed by the lens becomes the object for the mirror. Then the mirror will reflect and light will again travel through the lens as it comes out or comes back on the left side. So image formed by the mirror after reflection behaves as the object for the lens when light is coming back. Okay, let's do this. So first we'll consider only the lens. Tell me, if rays are incident parallel to the principal axis, where does the lens form the image? If rays are incident parallel to the principal axis, where does a lens form the image? Be it a lens or a mirror, if incident rays are parallel to principal axis, image will be formed at the focus. Okay. I'm assuming this is a converging lens. Okay, let's say it has a positive focal length. Its focal length is FL, focal length of the lens that is given to us. So let this be the distance FL. So these rays would converge as if they are going to meet at that point. Okay. But will they be allowed to travel till there? No, because this lens has a mirror next to it. So let me copy this diagram now. FL is the distance where the lens would form the image if nothing else was present. Okay, we'll call this as I1. So light traveling towards I1 strikes the mirror now. And where is the mirror? It is immediately next to the lens. Like this. Okay, you can, just for visualization purpose, you can assume a small distance between them, small gap between them. That gap is actually 0. Okay. Then these original rays which were traveling towards I1 become the incident rays for the mirror. And if those are the incident rays for the mirror, you can see they are converging rays. Therefore, this I1, which forms at a distance equal to FL, focal length of the lens, becomes the object for the mirror. Okay, virtual object. Let it be. Apply the mirror formula now to find out where the mirror now forms an image. Okay, let's consider only the mirror image formation now. So this is what is happening. Rays are incident on the mirror as if they are going to converge at I1. I'm just extending them for your understanding. Okay, so I1 behaves as an object for the mirror. Mirror's focal length is FM. It's a concave lens. FM is already negative. Okay, already given with the sign. Where is the object? Sorry. Yeah. Where is the object for this mirror? It is at a distance FL because the lens was forming that image at its focus. Okay. Let's apply the mirror formula now. 1 by V plus 1 by U is equal to 1 by F for the mirror. So 1 by V plus where is the object for the mirror? Rays are traveling to the right side. So for the mirror, anything on the right is positive and anything on the left is negative. You get 1 by V plus 1 by object distance is FL itself is equal to 1 by FM. Therefore, you get 1 by V is equal to 1 by FM minus 1 by FL. Okay, from that you can tell where the mirror forms the image. There are multiple possibilities. Depending on the angle at which the rays are incident, they may get reflected as if they form an image in front of it. Okay, that possibility is there. And okay, wait. Had these been parallel rays, it's a concave mirror, no? Had these been parallel rays, parallel to the principal axis, they would have converged at the focus. Now they are coming from even higher, even bigger angle, then they will converge somewhere here. Fine, the final image will be forming somewhere here. Let it be, not an issue. Okay. See, after substituting FM and FL, you will know whether V is positive or negative. Okay. Suppose this V is positive. Let V be positive. That means after reflection from the mirror, the image is forming somewhere here. How is that possible, you may ask? Like if it gets, actually for this mirror, it's not possible. Had it been a convex mirror, no, the rays would have gotten reflected like this and they would have formed an image here. Okay, but let it be, doesn't matter. Or you can assume V to be negative also, nothing wrong in that. Let's say V is negative, just to suit this case. Assume this is negative. What does V being negative mean? Image is forming in front of the mirror. Let the image form in front of the mirror. For this mirror, incident rays were traveling to the right. And if you get answer as negative, it means image is in the front. Let it be. This image formed by the mirror now behaves as the object for the lens again. Now, why does the lens come into the picture again? Because the rays are going back. After reflection from the mirror, the rays are traveling in this direction towards I2. Okay. But there is a lens in the way. It will have to, it will refract the light again. Fine. So now look at the lens only. Let us remove the mirror from this. Just a moment, I'll erase the mirror. The light that strikes the lens is like this, as if it is coming this way, as if it is incident this way. Okay, so I2, which is the image formed by the mirror, becomes an object for the lens. Okay, so light won't actually be allowed to converge at I2. The lens will disturb it again. So again, I2 becomes a virtual object for this lens. Let it be a virtual object, doesn't matter. But for the mirror, we assumed V is negative because for the mirror, left side was negative. But these rays, which are reflected finally and passing through the lens, for these rays, this side is positive and this side is negative. You have to change the sign convention. Not sign convention, you have to change the reference frame. So for the mirror, suppose image distance came out negative, that image formed by the mirror I2 behaves as an object for the lens finally. For the mirror, this side was negative distance. But for this lens now, that is positive distance. Therefore, object distance for the lens will be negative of image distance for the mirror because the reference frame has changed. Okay. And now we will have to apply the lens formula once again. 1 by V, this is the final image that we are looking for, minus 1 by object for the lens is equal to 1 by focal length of the lens. Okay. 1 by object for the lens is negative of 1 by image for the mirror. 1 by V is 1 by Fm minus 1 by Fl. We'll put it here. So 1 by the final image position, minus 1 by object of the lens. See, object distance for lens is negative of image distance for mirror. So negative of object distance for lens will be positive of image distance from mirror. So minus 1 by U can simply be taken as 1 by V from here, which is 1 by Fm minus 1 by Fl. So plus 1 by Fm minus 1 by, okay, 1 by Fm minus 1 by Fl is equal to 1 by Fl. Now send this that side. You get 1 by V final is equal to 2 by Fl minus 1 by Fm. Okay. Now let us draw some basic ray diagram here. You know how the rays are incident on that lens. And what kind of lens is it? Converging lens. Converging lens always brings the rays together. So what this lens would do to this light is, it would bring it closer to the principal axis and form the final image here, I3. This is what becomes, like this final image distance is what becomes the focal length of the entire system. Because this is the final refraction that is going to happen. Nothing else will happen after that. So that is the focus and the focal length of the final entire system. But see, for the lens now, for the light which is going back, this side is positive. Fine. And you will get this as positive only. But we are not looking for focal length of this lens. We are looking to derive the focal length of this silvered lens. For the silvered lens, which way was light incident? From left side. So for the entire system, if you see, this is positive, this is negative. But while finding the final image position, we took left side positive, right side negative. We'll get some answer. Okay. The actual focal length of the whole system. Therefore, 1 by V of the system. Okay, let me put it this way. This I3 is image formed by the lens. Final image formed by the lens. That itself is the final image formed by the entire system also. Okay. The entire system forms an image here. After all the refractions. Okay, wait. This is the original diagram. That last step that we did was written taking this side positive and this side negative. And we got this VF. But for the original system, this is the negative side. So we'll have to take a minus sign again. So 1 by V of the system is negative of 1 by V of the lens. Okay. So negative of this is what you need to take here. Therefore, 1 by V for the entire system becomes negative of this is 1 by Fm minus 2 by Fl. And this is what is the focal length of the silvered lens. Therefore, 1 by focal length of the silvered lens is equal to 1 by focal length of mirror minus 2 by focal length of the lens. Okay, so you just have to derive it step by step. Let's go through this once again. Our aim is to derive the focal length of this silvered lens. Fine. So what is the definition of focal length? It's the image distance when object is at infinity. So we assumed object is at infinity. Rays parallel to the principal axis are incident on it. So first they pass through the lens. We found out where the lens forms the image. That image behaves as object for the mirror. We found out where the mirror forms the image. The image formed by the mirror behaves an object for the lens for the light that is coming back. But for the light that is coming back, you will have to change the sign convention. Sorry, change the reference. Okay. Whatever it is, we found out where the final image forms. But remember, we had changed the signs in between. You have to change it back because you are looking to get the focal length of the original system, not this final lens. Okay. So we apply another minus sign and finally we get it this way, 1 by Fm minus 2 by Fl. Now let's see if this formula works for the last question that we solved. This one. Now one of you tell me, what does a silvered lens ultimately behave like? Is it on the whole a mirror or a lens?
Mirror.
It's a mirror because finally light goes back to that direction only. It doesn't go to the other side. Light goes back to the direction or the side from where it was incident. So it's a mirror effectively. Now we found focal length of the silvered lens. Okay, but this has to be treated as a mirror. Means if you want to find out where the silvered lens forms the image, you have to apply the mirror formula with this focal length, not the lens formula. Okay, so image formed by the silvered lens can be found using 1 by V plus 1 by U is equal to 1 by focal length of the silvered lens, because silvered lens is ultimately a mirror. Let's apply this to that water question. Okay, I'll copy this diagram. We are going to treat this water plus mirror combination as a silvered lens. Okay. If you want to treat it as a silvered lens, you need to derive its focal length. And to get the focal length of a silvered lens, we need to know the focal length of the lens and the mirror separately. Fine. Now this lens is made of water. Water refractive index is 4 by 3. Radius of curvature was given, I think, 20 centimeters. So consider only water as consider it as a water lens. Like this. How much was the radius taken as? 20 centimeters only. Fine. One of you quickly calculate, all of you quickly calculate the focal length of this water lens. Its refractive index is 4 by 3. The radius of curvature on this side is 20 centimeters. That side is a flat surface, means radius is infinity. Use lens maker formula and tell me the focal length of this water lens. Make it fast, I'll give you 1 minute. I got only one answer, and always Anugrah is the only one giving answers. Rishi, tell me the lens maker formula.
Sir, 1 by F is equal to N2 minus N1 by N1 into 1 by R1 minus 1 by R2.
1 by R1 minus 1 by R2. Okay. Now you can imagine light to be incident from anywhere. I'm assuming it is incident from the upper side. So R1 tends to infinity and R2 is 20. Whether to take it plus 20 or minus 20, you have to take it minus 20 because for that curvature, center is on the upper side, the negative side. So 1 by R1 minus 1 by R2. So this becomes plus 4 by 3 minus 1 is 1 by 3. Yeah, 1 by 3 into 1 by 20, 1 by 60. So focal length is 60 centimeters. So focal length of the lens is 60 centimeters. That's fine. And for mirror, we can directly tell. It's a mirror whose radius of curvature is 20 centimeters. What is the focal length of the mirror then? R by 2, 10 centimeters, but it's a concave mirror. We have to take it minus 10. Okay, we got FL, FM. Therefore, focal length of the silvered lens will be, what is the formula we derived? 1 by FM minus 2 by FL. 1 by FM minus 2 by FL. So effectively this becomes minus 3 by 30 minus 1 by 30. That is minus 4 by 30. Okay, this is 1 by F, sorry. So 1 by focal length of the silvered lens is this much, minus 4 by 30. This is what we will use now to find out the image position directly. For the water mirror combination, where was the object? Object was at 60 centimeters. Okay, so we'll take that as the object distance. We'll try to find out the final image distance directly. And as I said, we have to use the mirror formula. 1 by V plus 1 by U is minus 60 is equal to 1 by F. 1 by F is minus 4 by 30. You can take it as minus 8 by 60 just to make calculations easy. So you get 1 by V is equal to, send 1 by 60 that side, minus 8 by 60 effectively becomes minus 7 by 60. That means the final image forms at 60 by 7, minus 60 by 7 centimeters. And I think that is the answer that we got before. Wait, 80 by 7 was I2. And where was the final image I3 forming? I3 was forming at 60 by 7. And this problem is there in NCERT textbook also. Okay, like even in board exam, they expect you to be able to solve such situations. Don't use the silver lens formula there. You'll have to use refraction, reflection, refraction again. Okay, but I remember it is there in your textbook. Okay, see, Anugraha answered fine. You also just derive the silver lens formula once, and the others, all that we have discussed today, practice this once again. Questions like this are very common and very important also. Multiple reflections and refractions. Fine. Next class also we'll work on some situations like this. We'll take multiple lenses, lens, mirror, lens, something like. I'll try to find some questions like that. We'll work a little bit more on this, but I feel you people are not, like some of you are not confident applying the spherical surface refraction formula or the apparent depth formula. Okay, so I'll send you today's notes. Go through it once, whatever we have done today. Like solve the same problem on your own. Okay, and do this derivation of focal length of a silvered lens. Okay, fine. Thank you all. We'll continue in the next class. And we didn't discuss total internal reflection. That we will discuss tomorrow first. TIR, some applications of TIR, and we'll solve problems.